Alright, so for number 11, we are trying to prove or show that the left side equals the right side. So to do that, I'm going to change cosecant t to 1 over sine t using the reciprocal identity. And so with that, sine over sine, we get 1. Number 12, it's similar to 11. You could also change the cosine. It doesn't have to be the secant, so I'll do that for this problem. Secant y times 1 over secant y, because that's what cosine y equals. And secant y over secant y is 1. And you're done. So for 13, notice that I need a cosecant on the right side, and I have 2 right here. So what I'm going to do is I'm going to break up the cosecant squared x into cosecant x times cosecant x over cotangent x. And so from here, I will change it to sines and cosines. I only have the second fraction, not the first one. I'm going to leave cosecant alone. But this one here, I'm going to switch out to 1 over sine x over cosine x over sine x. So notice the numerator, denominator, they both have sine x in their respective denominators, so that is cancelled out. And so you have 1 over cosine x, so this is, let me just write it like this, cosecant x times 1 over cosine x, which is cosecant x times secant x, and you're done. So there are many things you can substitute for sine squared t or tangent squared t, but remember you always have to keep your eye on the goal. This is what you want to get to. So just by looking at this side, what I'm thinking is I'm going to take this one and change it to sine over cosine. So you have sine squared t over sine squared t over cosine squared t. And you know that when you divide by a fraction, you're actually multiplying by its reciprocal, right? So this becomes cosine squared t over sine squared t. So sine squared over sine squared is 1. The answer is cosine squared, which is what you, oops, I switched it over to x. It should be a t. For number 15, I'm choosing to work on the left side. So I'm going to make this side turn into this side. So notice how I have a sine squared and no more cosine squared. So somehow I've got to get rid of this cosine squared. Okay, I already have one sine squared, so I'm not going to I'm not going to mess with this one. I'm just going to replace this one with 1 minus sine squared beta. Okay, so that's my cosine squared beta minus sine squared beta. Combine like terms and you have 1 minus 2 sine squared beta, which is what we wanted. 16 is very similar to 15. I've got 2 cosine squared beta minus 1 here. That's my answer. This is my problem. So I already have a cosecant squared beta, right? I need 2 of them. So I've got to find a way of getting rid of this. Well, this is a part of a Pythagorean identity, right? So cotangent squared beta equals cosecant squared beta minus 1. And bring down the cosecant squared beta. Combine like terms, so you get 2 cosecant squared beta minus 1. And that's it. Alright, so I'm going to again work on the left side, make it look like the right side. And the key here is knowing your Pythagorean identity, well, knowing all your identities, but I've noticed that I've used Pythagorean identities the most. So this one is part of a Pythagorean identity. This one equals secant squared theta minus 1 plus 6. So that 6 minus 1 is 5. And that's it. So again, I'm working on the left side to make it look like the right side. Sine squared z is part of a Pythagorean theorem. So I'm going, or Pythagorean identity, I should say. So sine squared z is equal to 1 minus cosine squared z. So I bring down the 3, and 1 minus cosine squared z, and then combine like terms. 3 plus 1 is 4, minus cosine squared z, and that's what you want it to get to. Okay, for number 19, I'm going to work on the left side, and I'm going to distribute. I'm going to multiply the two parentheses, the two binomials. So I have 1 times 1 is 1. 1 times negative sine is negative sine x. And then sine x times 1 is positive sine x. And then sine times negative sine is negative sine squared x. Okay, combine like terms. So sine x minus sine x is 0. And so I'm left with 1 minus sine squared x. And 1 minus sine squared x is cosine squared x. And that's what you needed to get. For number 20, I'm going to substitute this with the Pythagorean identity. You know, this is part of a Pythagorean identity. Cosecant squared y minus 1 equals cotangent squared x. So I bring down the tangent squared y, and then this here becomes cotangent squared y. And so I can switch either one of them. It doesn't matter which one. I'll just switch out the second one. Tangent squared y times 1 over tangent squared y. That's what cotangent equals. And so now I have tangent over tangent, which equals 1.